So yeah, let's get started, guys, without any further ado. So as mentioned, today we go with what are classes. Again, why do we need these five separate classes as well? Okay. So as mentioned earlier, your IP addresses range from the number 0000, and they go up to the last value 255.255.255.255. And that entire range of IPs is divided in five categories called classes. Class A starts at 0000 and goes up to 127, 255, 255, 255. Since it's ending at 127, Class B automatically starts at 128, and all the 255s cycle back to zeros. So Class B starts at 128,000, and from 128 it goes up to 191, 255, 255, 255. Since it's ending at 191, Class C starts at 190. From 192,000, it goes up to 223, 255, 255, 255. Since it's ending at 223, Class D starts at 224. And from 224, it goes all the way up to 239, 255, 255. Okay. And since it's ending at 239, Class E automatically starts at 240. And from 240, it goes up to the last value, 255, 255, 255, 255. So the only four numbers you have to remember are 127, 191, 223, and 239. From these numbers, you automatically get the range of the next class. Class A, 0 to 127. Class B, 128 to 191. Class C, 192 to 223. Class D, 224 to 239. And Class E, 240 to 255. On the left side, you have all even numbers. On the right side, you have all odd numbers. On the left side, you have all zeros in the last three octets. And on the right side, you have all 255s. So it's an easy way to remember. And you have to remember these ranges, guys. These have been fixed by the people who invented IP addresses, and these ranges will be constant. They will never change. Okay. And in each class, again, there's a set of public IPs and a set of private IPs. So between 0 and 127, this entire range, there's a small range of private IPs from 10,000 all the way up to 10,255, 255, 255. So this entire range is the list of private IPs in Class A. Any IP within this range is a private IP, and any IP outside this range is a public IP. So private IPs are the IPs that you can use in your local area networks, in your intranet networks. Public IPs are the IPs used by the ISP, Internet Service Providers, to give you internet access. Okay. So you cannot choose your public IP, guys. It's provided by the ISP. But private IPs are in your control. You can assign any private IP of your choice to any device in your network. Okay. Similarly, in Class B also, between 128 and 191, there's a small private IP range from 172.16.00 to 172.31.255.255. This is the private IP range in Class B. Any IP within this range is a private IP. Any IP outside this, public IP. Similarly, in Class C also, between 192 and 223, there's a small range, 192, 168.00 to 192, 168, 255, 255. This is the private IP region, Class C. Any IP within this range is a private IP. Any IP outside this range is a public IP again. And in Class D and Class E, you don't have any private IPs at all. These two are exceptions. All of them are public IPs itself. Okay. If this is still a bit unclear, to elaborate on this, if you take the example of Class A now, it starts at the first IP 0000. That's what's mentioned here. And it ends at the last IP 127, 255, 255, 255. So in that entire range now of Class A, there's a small private IP set from 10,000 to 10,255, 255, 255. So that's the private IP set. Any IP within this range can be used in your local intranet networks. Okay. And any IP outside this range, which is from 0 up to 10, which is 9,255, 255, 255. And after 10, from 11,000 to 127, the last IP, these two are public IP sets. So in every class, in a similar fashion, you have a small private IP set and two public IP sets as such. Okay. Any questions? Yeah, for the first class, you would have to check for class A, you would have to check the first digit. So if it is 10, and if any other numbers can be from 0 to 255. So if the first digit is 10, it means it's a private IP. If it's falling anywhere outside 10, it's a public IP. For class B, it's slightly different. First number should be 172, and the second number should be between 16 and 31. Okay. So if it is falling anywhere outside 172 or outside 16 to 31 in the second octet, and again, remaining two can be anything. Last two octets can be anything, 0 to 255s. But first octet should be 172, and the second octet should be between 16 and 31. Okay. For only then it would be a private IP in class B. And finally, in class C, first octet should be 192, second octet should be 168, and the remaining two can be anything from 0 to 255. Okay, so those are the conditions. Right. I hope that's clear now. Right. So what we'll do as a small exercise is I'm going to write down some random IPs, guys. And looking at these ranges, you have to tell me which IP belongs to which class and whether it's a public IP or a private IP. So that is going to clarify this in a much better way. Okay. So let me quickly write down some IPs first. Just give me 1 minute. Excuse me. Okay. Okay. So I've written down a couple IPs here, guys. Now I want you to look at each of these IPs and tell me which IP falls in which category and whether it's a public IP or a private IP. Let me give you the answer for the first two ones, and the remaining ones can be answered by you. So first number we have here is 192.168.0.10. So the first number is 192. Where does that fall under? It's at class C here. If you notice, class C has 192 to 223. So therefore, this is a class C IP. Now, once we know this is class C, we have to specifically focus on the class C private IP range. If the first octet is 192 and if the second octet is 168, remaining two can be anything from 0 to 255. If this condition is being satisfied, it's a private IP. So first number here is 192, second number is 168, and therefore this is a private IP. Okay. Looking at the next number, 1, 2, 3, 4, 1 falls between 0 and 127. So therefore, this is a class A IP. Okay. Now, once you know this is class A, you have to look at the first octet here. So for it to be a private IP, first octet should be 10. Okay. Remaining can be anything from 0 to 255s. But what we have here is 1, which is outside the range. So therefore, this is a public IP instead. Okay. So that is how you classify which IP belongs to which category. Okay. Now looking at this next number, 10.20.0.20. Can you tell me which class and whether it's public or private?
Private, sir.
Okay, but which class?
Class A private IP.
Perfect answer. So this is a class A IP because it's between 0 and 127. 10 falls between that. And first octet should be 10 for it to be a private IP. So therefore, this is also a private IP. Okay. Next number, 172, 35, 45, 55.
Class
Class
B public.
Perfect answer. Class B. And this is a public IP. Why is this a public IP? First octet is 172. That seems to match. But the second octet is 35. Yeah, it's outside 16 and 31. So therefore, it's a public IP. Moving on. Next number, 192, 168, 0.20. Class C. Public or private? Yeah, so this is a private IP, guys. So if you notice, the first octet is 192, second octet is 168. These two are being matched with here. So therefore, that's a private IP. Next number, 172.20.01.
Class B private.
And okay, I've got one answer as public and one answer as private. Which would be the right one? This is class B, definitely. The first octet is 172. That falls between.
Private IP.
Yes, exactly. So this is a private IP. Correct answer. Moving on. Next one. 142.250. 193.221.
Class B public.
Perfect answer. Next one. 172, 172, and 230.
Class B public.
Perfect. Next one. Class C and private or public?
Public.
Public.
Yes, this is a public IP. Why is this public? 192. That seems to match. But here it's 169. For it to be a private IP, second octet should be 168. Since this is 160. Yeah, so you have to look at two octets here. Right. So since this is 169 and it's outside the range, it's a public IP. Next one, 100, 100, 200, 200. Class A and public. Correct answer. Next one. Class. Okay. So if it's not a private IP, then which one is it? Public.
Public.
Definitely.
Public.
Okay. Correct answers, guys. So this is how you've categorized which IP falls under which range. Okay. Now this is very important as mentioned in the last class, because looking at an IP, you have to figure out whether it's public or private and which category or which class does it fall under. From that, you can figure out where the attack is coming from. If it's a public IP, the attack is coming from an external source from outside your network. If it's a private IP, the attacker is in your own same network itself. Okay, so you can figure out where the source of the attack is by figuring out what the IP is as well. Okay, and I've also shown you how to check your public and private IPs as well in the last session. So if you have to check your system's public IP, you just simply go to your browser, and in the browser you search for what is my IP. And when you do that, you can see this is my system's public IP, right? Provided by my ISP, Internet Service Provider. So what I get here is 49, 204, 239, 240. Let me copy and paste that in the notepad file. Where is my notepad? Oh, I think I must have closed it. But now looking at this IP, can you tell me which class is it falling under, guys? Yes, this
Class
is
A.
class A. And is it public IP or a private IP?
Public IP.
Definitely public because it's falling outside this range. And if I had to check my private IP on the other hand, I can just open up my command prompt. And in the command prompt, I can run a command called ipconfig, Internet Protocol Configurations. And this shows me my private IP here. Looking at this IP now, can you tell me which class is it? Yes, 192.168.04. That's class C. And is it falling in the private IP range? Yes, it is. Perfect. Okay. Now, the main question that arises now is why five separate classes? Why not just one class with, again, some public and private IPs in it? It would have been a lot more easier. Why five different classes? Class A, B, C, D, and E. The reason why we have five separate classes, guys, is because network requirements are different. So the network requirement that I have at my home is definitely not what is required in an MNC company. Okay. Network sizes differ, the number of devices you connect differ, what type of devices you connect differ. Okay. So again, that is why you have different classes for each network size. Okay. Now let me explain this in a much more better way. So classes have something called network and host portions, guys. Class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has 3 network portions and 1 host portion. Class D and Class E have all network portions itself. There are no host portions in them. So as you, excuse me, as you're going down the line, the network portions increase in number and the host portions decrease in number. Class A has 1 network portion, Class B has 2 network portions, Class E has 3 network portions, Class D and Class E have all network portions. There are no host portions at all. Okay. But what do I mean by network and host portions? To understand this, we'll take the example of Class C private IP range. So we all know Class C's private IP starts at 192.168.0.0. That's the same thing written here, 192.168.0.0. Okay. And I'm going to write that down in a notepad file as well. So let me quickly open up my notepad again. So again, as mentioned, we all know that Class C's private IP starts at 192.168.0.0. And in Class C, guys, you have 3 network portions and 1 host portion. So the first 3 octets are network portions, and the last octet here is the host portion. Now, what do I mean by that? So according to the sequence of IPs which we learned yesterday, if you have the first IP as 192.168.0.0, next IP would be 192.168.0.1, next IP 0.2, next IP 0.3, next IP 0.4, next IP 0.5. So that goes on all the way up to 0.255. That's the maximum an octet can go up to. Okay. Why specifically 255? We covered that as well in the last class, right? So now once it reaches 255 here, what happens then? The 255 goes back to 0 again. So it cycles back to 0. And the next octet increases by 1. So then you have 1, 0. After 1, 0, same cycle. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Goes up to 1, 2, 5, 5. Then you have 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Goes up to 2, 2, 5, 5. Okay. Then 3, 0. So it's like that, the cycle keeps on repeating. Okay. But what we talk about network and host portions is over here. So when we are discussing this one specifically, host portion is to give the identity of every host in a network, and network portions are to give the identity for the entire network. So over here, each of these devices now can represent a unique or any individual host. So 0.1 could be my Wi-Fi router, 0.2 could be my phone, 0.3 could be my laptop, 0.4 could be my smartwatch, 0.6 could be my other laptop. As such, in this entire network now, I can connect a maximum of 255 devices. Okay. And when the network portion changes, when network portion changes from 0 to 1, the network divides over here, which means this is where the network ends here, and here a new network starts. So this is the entire 192.168.0 dot network. In this 192.168.0 dot network, we have hosts from 0.0 to 0.255. When the 0 changes to 1, the network divides here, and this starts a new network. Now, the devices in this network cannot communicate with devices in other networks. They can only communicate with the devices in the same network. Okay. So the 0.1 can only communicate with up to 0.255. It cannot communicate with 1.1 or 2.1 or anything. Okay. Because they fall in different networks. Okay. So each host here, again, or each IP here in the host portion represents a unique individual system. And the network portion is to give the identity for the entire network. So all of these devices are the 192.168.0 dot network. Okay. And in that network, this is the first device, the second device, the third device, the fourth device, etc., etc. So in each Class C network, in this way, you can connect a maximum of 255 IPs. That's what Class C represents. Okay. So with only one host portion, you can only utilize last portion for host. And with that way, in each network now, you can connect a maximum of 255 hosts or 255 IPs. Is that clear, everyone? Pearl, Pradeep, Hema,
Yes,
Aisha.
sir.
Right. Any questions up to this point? Right.
Sir, I have a question, Pearl here. So according to this, like all the devices in my house right now have the same IP address. Like the first 3 portions, network portions are same, and the last bit changes, right?
Last talk changes, exactly.
Okay.
So again, if you notice over here in my network as well, My system is getting the IP. Oh, 1 second. Let me open up my command prompt here. So my system is getting the IP 192.168.04. Okay. So again, the other device, if I connect one more device, that would be 05. One more device, 06. Okay. And my router here, router is called the default gateway. So my router is getting the first type, 192.168.01, if you notice. Okay. So the last octet changes, which signifies a change in the host, which indicates it's a new different host. Okay. A new device. Okay. So the first three portions signify the network ID. Last portion signifies the host in that network. As simple as that. Right? Is that clear? Pearl?
Yeah.
Perfect.
Thank you. And
Yeah.
one more question. So when you talk about communication between these devices, how can somebody from a different city contact? So you've mentioned that, devices in the same IP address can communicate with each other. So if my friend is calling me from a different city,
Mhm.
so
Yeah. So when I say your devices in the same network can communicate with each other, so I mean they belong in the same local area network. So in my Wi-Fi network, I can connect maximum 255 devices. So that's my local area network. When you talk about people from outside your network, that becomes a wide area network, a WAN, WAN. So for that, you need something called public IPs. So his device or his router will get a connection from his ISP, Internet Service Provider. And through the public IP, he connects to our system with our own public IP. So there's a connection of public IPs there. So we talked about what public and private IPs were in the last class. So let's assume this is our home network here. So my router gets 192.168.01, laptop 02, phone, smartwatch 03, smartphone 04. These are all the private IPs here. Okay. So your friend could be anywhere on the internet, okay, and he would have to use his public IP to connect to the internet and connect back to my devices here through my public IP. So there's a connectivity or transferring of data between private and public networks here. So again, that is all a different, much more wider network. So when I say connectivity is happening in your local network, it happens on private IPs. When it's a connection over the internet, it involves public IPs for that. Okay. So whenever you have to send data across the internet, you have to use public IPs for that. That's an important point, Pearl. Okay.
yeah, okay.
So
Thank
when
you.
I say private IPs, these are basically your local network devices. So if I show you a simple example here, I can go back to my command prompt. And just to check if I can communicate with my router, I can type a command called ping. So ping is a command which just sends some random packets to your device and checks for a response. So if I give ping 192.168.01, this is my router's IP. So when I send the packets, you can see. So my system is sending a packet of 32 bytes and it's getting a reply back like this. Okay, which means it is in the same network and it can communicate with it. But if I type ping and if I give an IP like 192.168, let's say 1.1 rather than 0.1, which is a different network. And now when I hit enter, you can see I don't get any response or reply back, which indicates that the request is timing out and it is not able to communicate with this device. Okay. So this is all related to your private IPs in your local network. Okay. So in my network, in those 255 devices, I can ping any system in this way. Okay. But when you're talking about a phone call connection or over the internet or a WhatsApp call or whatever it is, that involves public IPs again. So that's a different concept. Okay. All the communication that I indicate here is for your local area network. So in your own home network or in your local office, when you have devices and when you want connectivity among those devices, for that you use a private IP. For over the internet connections, you need public IPs for that. Okay. I hope that is clear for everyone, guys. Pearl, Pradeep, Hema, Aisha.
Yes, sir. Thank you.
Right. Moving on. So again, when you talk about class B now, coming to where's my presentation? Yeah. So moving on to class B, guys. So class B now has two network portions and two host portions. Okay. Class B starts at 172.16.00. That's the first private IP in class B. Okay. So after 172.16.00, next IP is 01, next IP 02, next IP 03, next IP 04. Goes on all the way up to 0255. After 0255, now this 255 cycles back to 0 and the next 0 changes to 1. Okay. So now there is 1 0. Now please note both the portions are host portions itself. So when it changes from 0255 to 10, they're still in the same network. So here the network portions are only defined by the first two octets. So as long as 172 and 16 are same, all of these devices can communicate with each other. So after 0255, 10 is just the next IP in the same network. Okay, then you have 11, 12, 13, 14, which goes up to 1255. Then 202.12223, which goes up to 2255. Okay. Then you have 172.16.30. Then you have 172.16.31, 172.16.32. This goes on up to 3255. Okay. Like that, the cycle keeps on repeating. And somewhere down the line, you would have 172.16.2550, 2551, 2552, 2553, 2554, finally 255, 255. When both these octets are filled, they cycle back to zeros now. And the next octet, 16, changes to 70. So same exact logic, just like class C. Whenever there's a change in the host portion, it just indicates a change in the host or the device. Whenever there's a change in the network portion, when 0 changes to 1, that divides the network there. That indicates the end of the previous network. Similarly, in class B also, as long as 16 is same, all of these devices belong to the same network. Okay. But when the 16 over here changes to 17, the network divides over there because that's the second octet, which is network portion. Okay. And similarly, from 1700 to 17.255.255, that's another network. After 17, you have 18. So the network divides again. So from 1800 to 18.255.255, that's another network. 1900 to 19.255.255, that's another network. Okay. So in the similar fashion, in every network now, we have two host portions. So two host portions in the sense in each network now, you can connect a maximum of 255 into 255 devices, which is closely equal to 65,535. So in class C, you could only connect 255 devices, but in each class B, you can connect 65,000 devices approximately. Okay. So that's the difference between each class. Class C is used for small networks, class B for medium-sized networks, where you have a requirement for more than 255 devices to connect. There you go for class B. Okay. So in my home network, I can go for class C itself. I don't have a requirement for connecting more than 5 or 6 devices. But in organizations, you have connectivity of more than thousands of devices. Okay. In such a scenario, to connect all those devices together, you go for class B instead. And similarly, when you talk about class A, it starts at the first private IP 10.0.0.0. So from 10.0.0.0, where we have one network portion and 3 host portions, all the way up to 10.255, 255, 255, all of them belong in same network. And when 10 changes to 11, the network divides over there. Okay. So therefore, in class A now, you can connect a maximum of 255 into 255 into 255 IPs, which is much larger compared to class B as well. Okay. So it's more than 65,000 devices. Okay. So again, practically speaking, you would never connect those many devices, but this is logically at least gives you the possibility. Okay. So class C only for 255 device connectivity, class B for 255 into 255, and class A for 255 into 255 into 255. Okay. The largest of all. Okay. Is that clear? Everyone? Hema, Aisha, Pradeep, Pearl. Yeah, Hema.
Yes, sir.
Right. Hema, any questions? Your mic was unmuted. Right. Now you might have a question. What about class D and class E? Right. So when you talk about class D and class E, guys, please remember they don't have any private IPs at all. So all of these networks and host portions are only for private IPs, guys. Class D and class E are all public IPs itself, but these public IPs are not given by ISPs again. So only ISPs can only use the public IPs from class A, B, and C. Okay. Class D and class E public IPs are not for internet connectivity. They're for special purposes or special organizations. So your military organizations, your government portals, your research and development organizations in the country, or your weather forecasting, weather broadcasting services. So news telecasting, all of those organizations go for class D and class E IPs. Okay. They're not the IPs which are used for internet connectivity. They're IPs specifically reserved for these special organizations. Okay. And there are no private IPs in class D and class E. All of them are unique public IPs for special purposes. Okay. So that's about the classes, guys. In tomorrow's session, we talk about what subnet mask is. So when we check the private IP here in the command prompt, if I type ipconfig, the first line shows our private IP. Last line shows our router's IP. But there's another line in between, subnet mask. So tomorrow we talk about what subnet mask is. Okay. And we'll also talk about a lot more important concepts. So what is subnet mask? How do you assign a private IP? So how does your system get a private IP in the first place? How can you assign it yourself manually? Or how do you get it automatically from a DHCP server? Okay. And what is a DHCP server? How does it give you an IP automatically? What is a DNS server? What is the job of DNS protocol? And what are special IPs? So we talk about all these concepts in the class tomorrow. Okay. So quite important and very crucial concepts in networking, guys. So I would recommend you join the session tomorrow without fail. Okay. And it's at the same time on the same link. So yeah, that's that for today's class. Nothing further, guys. So we can conclude the demo here and connect back tomorrow at the same time. Okay. Bye-bye. Or
Thank
in the
you, sir.
meanwhile, if you have any questions, you can let me know. If not, we can exit the session, guys. Yeah, Hema. No problem. No. Again, we are connecting on the weekends as well, right, Hema? So just in case, I'll share the recording for tomorrow's session. You can go through it, and in the meanwhile, over the weekend, anyhow, we'll connect back and we'll retake up the session which you missed out. How does that sound? Right, right, sure, sure. So tomorrow, again, I'll share the recording for tomorrow's session to you. And over the weekend, we'll connect back anyhow on Saturdays and Sundays, and we'll retake up that session separately, one-on-one. No, no worries, no worries, Hema. Again, as mentioned, tomorrow it's related to networking. So even if you miss out, day after tomorrow's session is completely unrelated. So it wouldn't be a problem for you. Okay.
Sir,
And
hello, sir.
in the meanwhile, you can go through the recording. And over the weekend, we'll take up a one-on-one session to cover that up if you have any queries.
Hello, sir.
Sure, sure, sure. Right. Yeah, Pradeep.
Yes,
Yes.
sir. I'm working. So there was any morning class from you? I joined today fast. Is
Not
there
from
any?
DURGASOFT, Pradeep, but I have my own private sessions actually on weekends. So again, if you're interested for that, you can let me know.
I don't understand. The voice was not clear.
Again, from DURGASOFT right now, there are no morning batches, Pradeep. Okay. But I take classes privately on the weekends as well in the mornings. So if you're interested, you can join the weekend batches.
Okay, okay. Only in DurgaSoft you have only evening class.
Evening class right now. Yeah, exactly. There's no morning batch right now.
Okay, okay, okay. Thank you. If I need to connect you, though, I connect?
I'll drop my contact number in the chat box. It's +91 984998477. You can contact me on that number. It's in the chat box. Pradeep.
Okay, thank you, thank you. I will collect you.
Sure, sure, sure. No problem. Yeah, Hema, you were saying. Yeah, again, we have the weekday classes every day, Hema, until this Friday. Yeah, it's every day. Yeah, sure, sure, sure. Definitely, definitely. Sure. I will. No worries, Hema. Sure. Okay, sure. No problem. Perfect. Sure. Bye-bye. Yeah, Pradeep, if you have any queries, you can contact me on my number. Okay.
Okay, thank you,
Have a
sir.
good day. Take care. Bye.